welcome you to this panel on engineering privacy into the internet on behalf of the EDPS, who is listed as the organizer. That's also the reason why I'm listed as the chair of the program, but for all practical purpose, I'm only a speaker, and I would like to hand over to our distinguished moderator for this session, which is Rob van Eijk from the Dutch Data Protection Authority. Rob is an IT specialist working there, also representing the Dutch and the European data protection authorities in international working groups, including in the W3C Do Not Track working group. And at the same time, working full-time, he's also finishing his PhD in the Netherlands. Rob, and that's your call. Thank you.
Thank you, Achim. Well, welcome to all panelists. And for those in the audience, the way we are going to structure this panel is through a conversation between the panelists rather than a sequence of presentations, just to make sure that you get the most out of this coming hour. In the end, there will be plenty of time also to interact with the panelists, because we will leave time for questions and answers as well. And to start, I would like to first question the panelists to introduce themselves, but also to explain briefly which factors led to poor privacy features of internet, and then just not only technical ones. Marit. Achim, you first, sorry.
Yeah, that's a bit telling the story of what we call the Internet Privacy Engineering Network, or an acronym is IPEN. IPEN is a widely used acronym with many meanings. So when you look for this specific IPEN in search engines, you best use IPEN privacy. It all started in the second half of 2013, when, among other revelations about mass surveillance techniques, it became also clear that many of the technical systems used in the internet were not really designed to protect privacy. They were not only having security weaknesses, but an analysis also shows that there are many programs and features and building blocks which are designed rather to collect as much data as possible than to minimize the data, and rather to disclose as much private information rather than to keep it safe. And what was the encouraging moment was that at the IETF conference, or the IETF meeting in Vancouver, which took place in November 2013, the internet engineers assembled there agreed on the statement that mass surveillance should be treated as an attack scenario with appropriate technical measures to prevent such attacks. And that we saw as the moment of an opportunity for the data protection community to get into stronger contact with the technical designing community, to say, let's work on this together. And that's how we all started to run this project/network, to first analyze and then find people that would cooperate with us to find solutions to this problem. And well, some of them we'll see on this panel, because many of them who joined at the beginning are here today with us. Thank you.
Well, thank you for that intro. So the question we're currently talking about is which factors led to poor privacy features of internet? And I'd like to ask Hannes for the reasons and his holds.
Thank you, Rob. As I tried to show on this slide, the internet software development process is a structured, distributed process, and so there are a couple of different stages which you can see on this slide. Starting with, or in the different processes, different communities are active. The topmost picture, you have the crypto community developing crypto standards, and what typically can go wrong there is, or what an example of a negative impact for security and privacy is if crypto algorithms become weaker over time as part of crypto analysis or get broken obviously then we've seen that with transport layer security, for example. A next community, a distinct community who uses the results of that crypto community is the protocol and the standardization community. I'm belonging to that community as part of my work in the IETF, and they define sort of overall architectures as you know them from, for example, HTTP and many other internet protocols. But then those are just, at that point, they're just paper. They need to be finally implemented by various different parties. And of course, many mistakes can happen there as well. We've seen a series of buffer overflow vulnerabilities with the Heartbleed as one of the most famous one last year, obviously leading to a significant impact on the security and privacy if keys get exposed and other credentials. And then as we move on, as companies then take different implementations and deploy them in their web service infrastructure and so on, they obviously need to make various choices as well in terms of configuration, a user interface, what their data collection and data use policy is. So you have in the different stages, you have different things that can go wrong, or put it the other way, where you could take privacy and security specifically into account. Thank you, Rob.
Okay, thank you. Well, apart from people who are active in the technical community, we also have DPAs involved, including the Dutch DPA. And I'd like to ask Simon to explain the motives of the ICO to join the IPEN.
Thanks, Rob. So if anyone that doesn't know me in the audience, I'm Simon Rice, the manager of the technology team at the Information Commissioner's Office. That's the UK's Data Protection Authority. And certainly if we look at the kind of breaches and incidents that cross my desk and the desk of my team, the most sort of common technical issues, there are a high number of those that could have actually been avoided. Those breaches could have been avoided. Or certainly the effects could have been mitigated if, in a lot of cases, that's some simple steps or actions had been taken by the organization. A simple example is keeping things up to date or patching software, or keeping a website, checking for vulnerabilities like SQL injection. And Hannes mentioned things like Heartbleed or shell shock. Now, accept that zero-day vulnerabilities will happen and will continue to happen, but it's certainly simply not acceptable that a system is vulnerable several months or years later to these vulnerabilities that are widely known. For example, the ICO published a report in May of last year looking at 8 common failures in IT security of online services. And there's certainly a significant overlap with those breach reports that we see, and the OWASP top 10, which is on the slides behind me. And again, for example, last week we issued an undertaking with the shoe retailer office in the UK after a database containing historical data was exposed basically to a poor decommissioning process. Even March of last year was a monetary penalty against the British Pregnancy Advisory Service because an attacker managed to get into their system through an SQL injection attack. Again, they should have been making those checks and making sure that those websites and things weren't vulnerable to those kind of simple aspects. And even in November last year, I wrote a blog about the dangers of not changing default passwords on IP cameras and other internet-connected devices, following a couple of reports about particular websites sort of listing those available devices. So I guess to return back to Rob's question, really, of what are those factors, poor privacy features, it's really those people just making poor choices, certainly at the outset, which leads to certainly some of these poor privacy features, perhaps using a default password or the same password across multiple services, or developers who perhaps cut and paste vulnerable code or not exactly understanding what that code does into new systems. Perhaps all system administrators who ignore their systems because they're running okay. They leave it for 5 years running under the desk because it's fine and I don't want to touch it. But say not keeping these things patched or up to date. Thanks, Rob.
Thank you. And now the mic's up to you, Marit. What's the reason for the ULD to join?
So the reason to join IPEN for ULD is my office, the Data Protection Authority of Schleswig-Holstein, Germany, the northernmost land in that country, and I'm the Deputy Commissioner. The reason to join is that we are not only interested in less data breaches, good security policies, but really in privacy engineering, so the heart of the term IPEN. And if you see here, the structure of our tasks that are all laid down in our Data Protection Act, so our legal basis. A typical thing are the first two pillars here. You see the supervision and consulting is also something which all DPAs usually do, but education and IT labs, so mimicking technology concepts on our own, trying out, having a look and feel with technology, and model projects where new technologies, for example on anonymization, can be tried out or further developed, where data minimization and not only the avoidance of security bugs play a role. This is something where we have an own section at my office. And in this area also some new ideas were born. For example, the data protection privacy seal, which we have since the year 2000, or an audit scheme we are doing with our public services. So this is our structure, and we have 1/3 of my colleagues are technologists and computer scientists, but we have an interdisciplinary team, which is also very important when doing this work, together with lawyers, of course, together with economists, and even some more disciplines. So I think for us it was very important if there's some initiatives from the DPAs with a strong link to the DPAs where technology, privacy engineering plays a role, we really want to be on the team. Thanks.
Thank you, Marit. So the next thing is there was another initiative that's been around already for a few years, the OWASP Top 10 Privacy Risks Project, which most of you may have heard about it already. The project supported IPEN already from the beginning, and it gives me the pleasure to introduce Florian. So maybe you can clarify your engagement with this initiative.
Yeah, thank you, Rob. My name is Florian Stahl, working for MSG Systems in Munich, and I'm project leader for OWASP as well, as Rob already mentioned. And for us, privacy engineering is not about only technology, it's also about awareness among those who design, implement, and control internet products and solutions. So IPEN is an excellent platform for us to exchange with experts from different areas and to raise this awareness and spread the word about the OWASP Top 10 Privacy Risks Project. So actually the Top 10 from OWASP that Simon already mentioned, this is the security vulnerability OWASP Top 10 project that maybe is known by some of you already, and we founded last year a new OWASP project that that addresses the privacy risks in web application. Why did we do that? For many years, there are still many privacy risks in web applications, and this happens. Many of these web applications might be compliant to the laws because they are hosted in countries with poor privacy laws, or they focus on paper compliance and not on the real-life risks that the data subjects are confronted with. And when we started our research, we found out that there are no guidelines or no statistical data about privacy risks in web applications. So that's why we founded this project about 1 year ago, and we wanted to discover the most important technical but also organizational privacy risks in web applications. So for those who don't know OWASP, it stands for Open Web Application Security Projects. It's a non-profit and open source community. And we succeeded to motivate nearly 100 privacy and security experts to participate in this project with the ultimate goal to help developers, but also business architects and others to understand and improve web application privacy. And I will tell you a little bit more about the results later on.
Thank you, Florian. So in addition to industry and regulatory perspectives, it's also important to connect to academia. And for that, we have Jaap-Henk in our panel, and I'd like him to ask him to explain his engagement with the IPEN.
Thanks, Rob. My name is Jaap-Henk Hoepman from the Radboud University Nijmegen in the Netherlands, and also from the Privacy and Identity Lab. I will tell a little bit about that later. I'm from academia. I do research in privacy enhancing technologies, privacy by design, applied cryptography. I'm a computer scientist. But I do enjoy engaging with lawyers and policy people because that broadens my perspective and also gives me good input for research that is really relevant for computer scientists, that really helps you define problems that are new in our area. Some of the research we do are, just a few examples, we do research in, say, privacy-friendly forms of identity management based on so-called attribute-based credentials. And we have one project that we have is called IRMA, where we implement these technologies on smart cards. And the reason why I mentioned this, and this is also in relation to the original question that Rob raised, is what are the factors that led to the poor privacy features of the internet. One of the aspects here is that usability of the technology, and making sure that people understand the technology in the right way, that they understand how to use it, is something that for engineers is typically a hard thing to do. It's not something that we naturally consider. So in this IRMA project, this is one of the things that we really focus on to make it usable in practice. So we really try to bring this technology into the society, which is, again, something which is for university all by themselves hard to do. So this is one of the reasons also for us to join IPEN, to really have this dialogue, this platform of both exchanging ideas, but also finding people that are interested in joining these kind of research projects to bring the output of the research more into society. So that's one of the other examples, our Internet of Things. This is something that is really still upcoming. We're really looking into, how to frame the Internet of Things, what are the privacy risks there, and also looking at ways of solving the issues that are there. And finally, and I think that's the main topic that is relevant for this panel, is research on privacy by design, and especially privacy design patterns.
Okay, well that brings us to our second question, and that is, what can engineers do to improve the privacy features of their products? And in order to tackle this question, I would propose a tour de table, and start with Jaap-Henk, and Marit, and Florian, Hannes, and then Achim. And you all have about 2 minutes to defend your position.
Wow, 2 minutes. Let's go. To defend the position, I think the first thing to use in defense of our position is the report that Marit and I and others recently published, commissioned by the ENISA on engineering privacy by design and data protection by design, which shows you a lot of the technology out there, and which also shows that there's still a large gap to bridge in order to ensure that this technology is actually used. And I think my position in this is actually symbolized by the other picture on the slide, where you see this software development life cycle. And privacy by design is really about ensuring that privacy is incorporated into the design of the system from the very start. Now, if you look at the tools and things that we have been providing as engineers for the practitioners out there to do this, we've built privacy-enhancing technologies. There's many privacy-enhancing technologies out there, but they're only relevant for the implementation phase in this software development lifecycle. But that's very late. So at some point, people started thinking, okay, maybe we should make this more, usable for people. Maybe we should try to bring this more in front of the cycle, and people started thinking about privacy design patterns. This is a step forward, or in a way backward along the circle, and gives engineers at least some handles on approaching the problem and designing systems in a privacy-friendly way in the design phase. But that still does not really help them designing systems in a privacy-friendly way when thinking about the concepts and when analyzing the systems. And that's where some of the work that I did on privacy design strategies, which are very high-level, say, goals that a system might want to achieve in order to be privacy-friendly, have been defined, and they can be found both in the ENISA report and other papers that I wrote on the subject. So if you're interested, just look them up. But I think it's important to make sure that, especially in these first steps in the design, where you're not really sure what you're building, you're not really, you haven't really, set yourself in one direction, that you actually start thinking about, okay, how can I sort of roughly set up this system? How can I roughly divide the data? What kind of protection mechanisms can I use? How do I conceptualize the system? These things are very important to ensure that you actually have systems that are privacy friendly from the start. Thanks.
I think I was next, okay. So Jaap-Henk is already connecting to the principles of software engineering, so software development, and talking in the same language then as the engineers. And we do the same, also trying to connect to already understood concepts, because then it's very much easier first to say it's not already solved by, for example, if you do security, privacy is already done as well, but also to use perhaps the same methodology where it's possible. And therefore, we are very much working with privacy protection goals. So protection goals from the information security field are well known. It's the famous CIA, and I don't mean the Secret Service, I mean confidentiality, integrity, availability. And for the privacy perspective, we first, as DPAs, were reduced to, okay, you may be involved in confidentiality. That's your task and the rest is our task. No, it's not that easy, because confidentiality does not tackle all human rights, all possibilities, everything we want to see. And also the attacker model in security and in privacy usually is different. So from the security point of view, you often have a look from the organization itself, and then it may be that the organization has to safeguard everything against, for example, its customers, the consumers, the people, the individuals, the citizens. And from the privacy perspective, the attacker model involves the organization itself. So the organization, where you are the customer, they may be attacking you, so by tracking, for example, and profiling you. So this is something where we have a difference, but still we can use the same methodology, working with protection goals. And here we have the 3 additional protection goals, which since 6 years now have been proved to be usable for especially upcoming technologies where it's not so clear what the law will state in a few years, like ambient assisted living or smart cars or something. And one is very clear. I mentioned already anonymity, so data minimization, and we generalize it here with the term unlinkability. So separation of processes, purpose binding, everything it's already known in data protection law, of course. The other thing is transparency, everything, how people can understand, the individuals, but also the supervisory authorities or the organization itself, what is happening. And it's not sufficient to tell, this is how it works, take it or leave it, this is your own choice, but really how to do informational self-determination, how to influence something. This is under the term intervenability. The native speaker tell me this is a bad word. In German, it's also a bad word. It's not very much known, which is good because it's not already taken over by other interpretations. There are very few mentioning outside the privacy field, and it's really about the possibility to intervene. And if you want to know more, I can talk hours about it, but I'm not allowed. I've seen the sign. Thanks.
Okay, thank you, Marit. So what we from OWASP did as a first step, we were considering web application privacy. We tried to identify the most important risks that have to be addressed by engineers, and we asked privacy and security experts what are the most common privacy problems, also with the most impact that should be addressed, and the result was the OWASP top 10 privacy risks list. And the first risk actually were web application vulnerabilities that were mentioned by Simon already before. The second risk was operator-sided data leakage, so that is about like insufficient patch management or not insufficient access management at the data processor. The third risk is insufficient data breach response, that breaches are not reported to the individuals or to the authorities, or that the root cause of the breaches is not fixed. The fourth risk is insufficient deletion of personal data. The fifth risk are non-transparent policies, terms and conditions, so policies that are not easily readable or understandable for non-lawyers, or that don't provide a full transparency about what happens to the data. The sixth risk is collection of data that is actually not required for the purpose that the user wants to process his data for. The seventh risk is sharing of data with third parties, so that's mainly about widgets that for advertisement or for social network buttons that are integrated into a web application and that transfers data directly to a third party without the user being aware of it. The 8th risk is outdated personal data, so data that is old or just false. And the 9th risk, it's actually quite interesting one. It's missing or insufficient session expiration. And for me, as a security and privacy consultant, of course, we tell web application providers you have to have a appropriate session timeout. But having a look at like Google or Facebook, you won't be able to configure an automatic session timeout there, like maybe automatic logout after 1 hour, 1 day, or 1 week. And of course you ask yourself why. They might have good security people, I'm sure about that, but of course they want to collect personal data as long as possible, and therefore they don't provide this option. And last but not least, the 10th risk is insecure data transfer, which is mostly about missing or insufficient encryption of data during transfer.
Thanks. Yes, I mentioned earlier, I'm involved in standardization for a long time in the Internet Engineering Task Force, and so it was quite natural to start working on guidelines for engineers developing sort of systems in that community. And I worked together with the Internet Architecture Board to come up with a publication which you see a screenshot on the screen. This is an RFC that provides information about privacy threats. It provides information about terminology, so that different authors actually, or different engineers, use the same language and don't talk past each other. Provides us privacy services, similar to what Marit was talking about, and many questions that the engineers should ask themselves when they design new systems, so they actually make a conscious decision about what they are designing. And we're using that document now inside the organization, inside the Internet Engineering Task Force, for review of documents, like we did for a long time on reviewing documents with respect to security. Another more recent development is in the W3C, who is trying to develop similar guidelines, but just for web applications. And of course, the OWASP, or the insights from the OWASP project would be very valuable in that regard.
Thank you. Well, our consideration was that we need to address the possibilities and the tools available for engineers to properly deal with privacy issues in the development. So the basic assumption was that, and is that most people don't intentionally design and implement bad privacy in their tools, but that on the one hand there are no proper tools, there is not methods to properly recognize privacy issues, and there's no proper way to translate privacy requirements into technical tools, and it's not an issue which is systematically part of the engineering education. And so that's also why when we were looking for co-operators for IPEN, we looked in all directions. We have industry, we have many of the regulators, and we have academia, so that we can go in all directions to address the problem. And the idea of the network is to help initiatives already active in that field, like what is happening with the privacy interest groups in IETF and the related internet things like OWASP, like what our colleague regulators have been doing, and the relevant research to bring it all together so that we can have synergy effects, and the different initiatives can each encourage each other. And well, at the beginning we didn't know that whether it would work, but I'm much more optimistic after having seen how it took off, and how many people have actually felt the need and the interest to support this initiative, and we'll hear a bit more about that later in the panel.
So we've already mentioned, a number of different people here on the panel have mentioned security as a way of getting some quick wins, where there's certainly that first OWASP top 10, and then highlighted those security problems. But as we know, good security doesn't immediately equate to good privacy. So then if we looked at that second top 10 list from the OWASP privacy project, we've got those other fundamental principles, such as proportionality, transparency, and accuracy. On a practical level, you can think about for those engineers, is it appropriate to be processing that quantity of data? Do the users know that it's being processed? Or can the user be given effective controls to limit the processing or collection of that certain data? And certainly it's engineers and developers that are in that primary position to influence these decisions on a practical level, certainly again during the design phase of a project. We can look at existing project management phases. Can we integrate a privacy impact assessment or PIA? Now I'm sure I didn't hear any, but sometimes there's a groan when you mention a PIA or risk assessments in a design phase. But it certainly doesn't need to be onerous. And certainly, small projects, just adding a little box in your design documents, asking a simple question: are you processing personal data? If yes, go and speak to someone that knows about these kinds of things. Or a box, what are the impacts on user privacy of this project? So just getting those questions out there can be enough to sort of stimulate the engineer's mind. And they will be the most innovative and productive minds in your organizations thinking about these new projects. So that if they're mindful of privacy, in that design phase, they can help engineer out any potential problems.
Okay, so this whole train of thought and perspectives was started by looking at the causes. And then we asked ourselves the question, what can we do from a technical perspective? And that brings us to the third question. How can we enable better privacy? And to deal with that question, I propose to shuffle the tour de table a little bit and give first the floor to Achim, then to Jaap-Henk, Hannes, and then Marit, Florian, and then Simon.
Yeah, thank you, Rob. The kind of, for this kind of initiative, I think it's necessary to have some reference point in time to work towards and then walk away from. And so after a lot of work had been done offline and over the net and in partly meetings, we planned a workshop to get all participants together, which was in Berlin in September last year, and I'll come back to that. And there we had good representation from industry, from regulators, from academia, from civil society, and free and open software initiatives. And we discussed the questions on how to address this issue. And at the end, we came up with a list of 10 action points or action lines or initiatives, which you see on the slide behind us. And the first one is called the Developers Cookbook. That's basically to be in the metaphoric sense a collection of recipes for typical privacy problems that developers can come across in the process, and then address it. And the second point is that many people said in the workshop correctly, well, if the developers want to implement privacy, they need the users, the customers, the marketing, the product design people to agree to that, and also the business processes have to be designed to be in line with privacy requirements. So that's a second task, which definitely has quite a number of challenges. Then the security issues of communications were, of course, one field identified. It was also raised that when you have a network of so many projects, and these projects need funding, and we also have identified that as a point to work on. One very concrete project that was discussed was to come back to machine-readable privacy terms or privacy policies to see whether there's any possibility to implement tools like that already in the communications tools. A subset of secure communication would be short messages, phone, and so on. And bridging between lawyers and techies, well, I met privacy experts and engineers in general. We want to collect the resources. There's already a lot available, and we want to make that more accessible by concentrating information. Certification is a possible tool, and the last point, choice of tool, here refers in particular to procurement processes to help people who design procurement terms of reference to take proper account of privacy features when they select tools. And all of our panelists are involved in one or the other of these initiatives, and they'll say a bit more on that, and Jaap is the first one.
Thanks, Achim. Yeah. So when meeting in Berlin, I volunteered to take up responsibility for the so-called engineering cookbook, and apparently we were all in a sort of cooking kind of mood. But before I go into that in a little bit more detail, actually the reason to commit to that is the fact that we have a project about to start next month called Patents for Privacy, where we're actually going to investigate and develop privacy design patterns, and both create a, say, general template for that, investigate the patterns that are out there. Our initial investigations actually show that there's surprisingly little usable privacy design patterns out there. And then also look at how you can connect that both to what Simon already mentioned, the privacy impact assessments. The results that come out of that should actually be easy to map onto the design patterns that can be used to solve the issues that sort of surface from this impact assessments. And then the second question is, okay, if you have these design patterns, how can you then make it easy for system developers to actually use and apply these design patterns within their ordinary development process? And then actually this is both at the, say, the system design, the engineering perspective, but also at the organizational perspective. How do companies, you know, in an organizational way, deal with privacy impact assessments, and how do they streamline and organize their product development approaches? So that is something that is actually going to happen in this Patents for Privacy project, and the results of that will be fed into this engineering cookbook. If you go to the link that you see there, the GitHub, you will see the initial setup of this cookbook, this engineering cookbook. Everybody is free to contribute. Instructions on how to contribute can be found on this link on this website. And as a final remark, the privacy design patterns themselves will be made available through this repository that will be the output of this Patents for Privacy project, and that's on the link on the bottom of the slide. And especially because this is such a in a way new approach and definitely a new field of research, like much less technical than the stuff that I'm used to do. I really look forward to your feedback to all the stuff that's happening out there. So please contribute and tell us what you think.
Yeah, my key message is to take the entire development cycle into account. And as you have just heard from Jaap, with his cookbook, he's essentially focusing on the deployment part, a similar, basically a version of the bettercrypto.org handbook that provides guidelines for configuring software securely, and this is sort of the privacy version of it. But of course, there are other parts that also need to be taken into account. Think of it as a building. The foundations need to be correct, otherwise the parts that fall on top of it are not really safe either. And you can think of it as a developer, as an ordinary web or a smartphone developer. He doesn't reinvent the internet from scratch. He doesn't normally would want to develop new cryptographic algorithms because he probably doesn't have the expertise. He will focus on what he knows best. He has some brand new idea for some application, and he reuses lots of the code bases that others have developed. And of course, he needs to be confident that that prior work has also taken security and privacy into account. And that's why the other steps need to be addressed as well. And there are different projects, and connecting those is part of the work that happens in IPEN to get these different communities, often disconnected communities, talk to each other and to share their work.
Okay, so Hannes was also mentioning kind of repository of building blocks, of concepts, or something like that. This could be one of the topics of this action item. We know that if you take existing building blocks today, you usually don't have the best solution because most building blocks are not designed for some privacy enhancement. But even if you take privacy enhanced building blocks, then it's not guaranteed that the result will be privacy enhancing or privacy compliant or compliant to any law. And a guarantee is always difficult. It's really also a basic research problem that the privacy features are not necessarily robust if you combine building blocks. Still, I'm also in favor of having those building blocks. But what we also need is, for the full life cycle, how do they get together? What about interfaces? Does it really yield a product or some procedure which can fulfill privacy criteria? And usually DPAs are known to criticize and be angry about something, but we also want to be positive about things that are positive. And this is our motivation for the privacy seal. I mentioned this already, that we began in the year 2000 with that, to develop criteria that can be applied, that can be seen, sometimes have to be balanced before, have to be spelled out. And we had the experience that if only one entity does a check, then very often they, copy pages of the manual or of the marketing speech or so. So that's not really a guaranteed success. And from security, again, I mention again security as a security protection goals. We know that there are standards having 2 steps in this process, and this is what we also did. This does not mean that other seals won't work. It's only what we, from our experience, see that auditors that are independent again from us can have a look, but do a good evaluation, have to report, have to prove that this evaluation is good and plausible and whatever, and we check. And very often they fail. So even if the auditors say, yes, everything is all right, we say, but you haven't considered this here or that, because perhaps they didn't recognize, now it's with RFID and with the cloud service and with marketing and online tailored behavioral targeting. So things they might have overlooked, and so we have to say, you have to improve. Otherwise, we are not shy to say, yeah, but this is now something, you really achieved something. We can say, this is all right in this version, keep it that way, progress, and it's not forever, of course. It's something we can certify, you can document, and this is also something where I'm really asking for. It's not only to be legally compliant, it's also to document, to having a short report on what is happening, why is it privacy and legally compliant on the website, on the certification body's website, on your own website, but also to spell out why is it above the norm. Usually it would be all right to be legally compliant, it's already sometimes difficult enough, but usually those who are interested in privacy seal really have something where they enhance the state of the art. And this is what I'm envisioning, not only having old technology, everybody's doing the same stuff and no improvement, but that we really can see different progresses for better unlinkability, for better transparency, for better intervenability, and then they can state it, they can prove it, and this is where I think we get progress. It's not a necessity that IPEN does certification, but it's only that we have to think about certification also because the regulation will have something like that in place, and also how's the link with the repositories, with the patterns? Is this something where we have one big picture where everything fits in? This is our task there.
So what we from OWASP are currently doing also to deliver input to the developers cookbook that was mentioned by Jaap before, and we are collecting countermeasures to the risks that we identified. Like one example would be like not forwarding personal data from websites to third-party advertisers or social networks before the user explicitly triggers it. Like YouTube provides, for example, a privacy-enhanced mode where the data from the user is not transferred to YouTube or Google before he triggers really by clicking on the video. But many engineers don't know about such options and do not implement them therefore. So there are many examples that we try to find countermeasures currently. So if you're interested to know more about the status and about these countermeasures, you can have a look at our website. You will find it if you Google for OWASP and top 10 privacy. And one note from my side, we are also looking for a master student currently that will help us with identifying countermeasures. So if someone of you is interested or knows someone, preferably for the area around Munich, feel free to contact me.
Well, certainly education is also clearly an important part of this. different people have different perceptions of what privacy is, and certainly engineers need to be aware of, well, what is expected of them, certainly from the legal perspective, but they also be aware of what do their users expect of a certain product or a bit of software. You know, certainly moving into areas of big data or big everything, really, you know, bandwidth, storage, or processing power is pretty much unlimited for most applications. So certainly a growing temptation for engineers and projects to do things just because you can, rather than just because you should. Certainly I've even seen some engineers perhaps coming back with a response, you know, claiming a system processes data in a particular way, you know, because they were told it needs to do that. You know, engineers need to be aware of privacy engineering. But I think also we can, certainly from IPEN and the ICO and other data protection authorities, can show that how privacy can be used in a competitive environment. You know, we like to publicize the mistakes of other organizations to help show other organizations, engineers, to use those enforcement actions as case studies, show that those risks of getting it wrong and how doing it right early on is certainly obviously makes things a lot easier and help avoid that particular kind of enforcement action that may follow on. Thanks, Rob.
Well, thank you, Simon. When you ask a lawyer what changes society, chances are that he or she may respond, of course, it's law. However, if you ask a technologist, they may come with an orthogonal answer and may state that society is changed by technology. Well, this is an illustration that there is a gap, as Achim already pointed out, of a disconnect between the lawyers and the technologists. And that brings us to our last question, which is, how can we bridge the communication between lawyers and technologists? And I propose the following order, to start with Marit, and then Jaap, Florian, Achim, and Simon, and Hannes as closing.
Okay, thank you. So our approach is doing work together with other disciplines. So really working within our office in different disciplines. I already mentioned that we have technologists, computer scientists, but lawyers, of course, people from administration, knowing the processes in government by heart, or economists. But usually we cannot hire all the time, but what we can is being engaged in projects, and then we can hire staff and also have the synergies of communication within our own team, but also with the project teams. And you see here, from our experience, we started quite early, also in the 90s already, with work on anonymity, providing an anonymity infrastructure for surfing, web browsing, with a German project called Anon. And so this was really on something, how to develop privacy-enhancing technologies, not only compliant on the lower bottom level, but really something on an enhancing projects. And these projects I like best because mostly people are already, it's easy to have the same vision. They are already aware. They know they want the same, they want to improve something. And this happened in the projects on identities management, plural, with Prime Life, ABC for Trust, where we went to the European level, because this is also something interesting. The cultures are different, and the communication and the solutions are different. And so this is something I learned a lot, and I think this makes a difference. But then there are more projects who have a task of privacy by design. It's not that they really want to develop privacy-enhancing technologies, but they want to do it right. And I think this is also something we want to promote. For example, in the cloud area, where we are not that much interested in resilience of cloud computing, but if it's part of the project, and also our tasks are part of the project, we can also join. And so we did this in T-Clouds, or in the German project Split Cloud, where we split administrators' access according to the needs, or on cybersecurity with the project Monica. They're often female names, by the way, mostly by male projects. But what we also are, what we're also seeing is that we often need more discussion, and not only development or research, but really something for practice, or where we have to sit back and rethink some concepts. And this, for example, we are doing in projects where it's about participatory design, or academic summer schools here, the IFIP summer schools this year will take place in Edinburgh. Several of you are already involved, or I hope will be involved, because this is some good opportunity to meet different disciplines. And the recent project we are involved here is the Privacy Forum. Tomorrow there will be a panel on some of the results where we have 8 disciplines together. And we see where we have already so good experiences with technologists and lawyers and some other disciplines, and psychologists are involved. But sometimes it's hard if we have to rethink everything from their perspective again. So in the beginning, interdisciplinary exchange is sometimes quite hard, but then I think later on it's a win-win situation, but sometimes in the beginning it's hard. Still, I believe that we should go that way and also get back the results then into the data protection authorities.
Yeah, to follow up on that, actually, I think it all starts with education. So we have a security masters at the University of Nijmegen together with Eindhoven and Twente, and we do not only teach like technology. We also have like a course on law in cyberspace, for example. And one of the interesting experience we always see here is that if you look at the computer science students or people, they are really binary. They really think that, you know, a solution is either wrong or right. Then again, if you talk to a lawyer or a policy person, he will look at the solution and say, well, you know, it depends. You know, there's many different shades of white and black and gray and in between. And for a computer science, this is totally unimaginable. It is very hard to deal with this fuzzy world out there. So it's important to let the students, you know, experience this and deal with this. And then also in the privacy seminar that I teach, we do that. We actually give the students a concrete task to look at real problems out there in the field. Look at it both from a legal perspective, so what is the problem here, from a normative perspective, and then trying to map existing solutions, or if they're really clever, new solutions to that problem. And sometimes that, you know, gives very interesting and new results. In a way, the same approach we have in the privacy and identity lab that we have, where you realize that if you want to solve the privacy problems that are out there, only technical solutions will not work, because we may think that we are the binary bit 1, we have the solution, but society may think that it's, you know, crap or not really useful at all. So what we try to do here is bring the lawyers and the social scientists and the computer scientists together, and not only do the academic research, not stay in this ivory tower, but actually go out and talk to our stakeholders, talk to government, talk to businesses, and tell them about the stuff that we do, and listen to the problems that they have, and try to actually solve their problems together with them, because that's also interesting for us, because then we actually, you know, discover new, interesting problems that are relevant in the real world that we never thought about, and that actually can be turned into very interesting academic research questions. So I think this is part of the way to approach this and bring this forward. Thanks.
I can just agree with you, Jaap, that it's really important to bring together technologists with lawyers and business people, and how we are trying to do that. We are cooperating with the International Association of Privacy Professionals to spread our knowledge that is more coming from the technological side, also among lawyers, and discuss with them what help they need to improve privacy on the internet and in web applications. So, and also IPP helped us to find the right people to participate in the project, and we are presenting our insight at their events, like the Global Privacy Summit, for example, in Washington now in March.
Thank you. For data protection, I mean, there was a point in time, luckily it's not now, where what I sometimes said is processing of personal data is happening 100% with IT, and the data protection authorities have 100% lawyers working on that. So luckily, this is long ago, at least since 2006, when the data protection authorities at the international conference had what's called the London Initiative, where they recognized that they had to become more aware of technology. And since then, we have seen a lot of change, and that's why partly visible by having 4 representatives of data protection authorities with a technology background on this panel alone. And there's certainly a lot more people with these 2 combinations here at this conference. And we saw many of them at the workshop in Berlin, of which you see a photo here. I think we had like 8 or 10 or so data protection authorities present in that workshop. The bridging between lawyers and technologists, of course, goes both ways. And one important element that we have just seen on this panel is the privacy objectives that Marit defined in her earlier statement with the concept of unlinkability, which is going beyond anonymity and making it more operational, including facets which are in the relatively broad and fuzzy term anonymity not included. And I think this is a task for us technologies to translate it to those working on the data protection reform at the moment, because I've never seen so many misunderstandings about anonymity and pseudonymity as in some of the legal proposals and amendments made to that draft. So there's certainly a task for technologists to go into that field. So I think here's a particular responsibility of data protection authorities to bring these 2 fields of expertise together. And I'm quite glad to know that my own employer, the EDPS, is very well aware of this, which is one of the reasons why I'm here, of course. And so we can only encourage and also say that authorities are indeed willing to work together with technologies from all walks of life on this.
Well, certainly bridging any communication gap between lawyers and technologists is one of the goals of the technology guidance that the ICO publishes. Certainly our mobile apps guidance that we put out was primarily targeted at app developers. And cloud computing guidance that was a few years earlier was targeted to really highlight the key questions that data protection officers need to answer or need to get answers to when discussing procurement with either IT departments or a cloud computing vendor. Even in some cases, just giving data protection officers a list of those key questions or key phrases that they need to ask technologists can be of assistance. For example, when did we last have test our code for SQL injection? When did we fix all of the results of last month's penetration test? Data protection officer doesn't really need to know what those words really mean, but they certainly need to know what the response is, and they are getting the right response back again. I'll certainly also argue, suggest we do need that higher ratio of technologists, in terms of data protection and privacy roles. Not exclusively the area of lawyers, but of course, I'm a technologist, so I'm a bit biased in that response. Yes, definitely, certainly more technical skills in there.
As the other speakers already said, I also believe that one core mission to close the gap between technologists and legal people is simply information sharing and education. And from Achim mentioned already the workshop, which was only one example. I've been involved in a couple of other initiatives earlier, and I list 2 examples here, where we tried to gather input from different communities. We didn't specifically just ask for lawyers and technologists, but there's also a wide range of expertise available in the community. And one was a workshop on Strint that was done in London together with the W3C to specifically focus on questions that were raised with the mass surveillance that Snowden revealed. And so we were asking, what can we actually do to deal with these type of things? And there were technological issues discussed, but also legal issues. And the proceedings are available, so it was an open call for input, and we got lots of professionals showing up. We also did a workshop at MIT from the IAB, from the Internet Architecture Board, to focus on privacy engineering. And in the same format, reports are available, slides are available, open participation. And so to actually reach out to the wider community to get that input, because some of the questions are not so easy to answer. So you need to get a lots of different views to actually come up with a reasonable story. And the output of that workshop led to the publication of the document that I showed you earlier on the screen. One important point that I still want to stress at the end is this open participation, the transparency also in the process of working on these type of things. So when we produce those standards and these recommendations in these organizations like the IETF or the W3C, we want to make sure that there's a possibility for everyone who's interested to participate with a low barrier of entry, because otherwise you may exclude communities like civil rights organizations or others, and we don't want to do that. And make then the results available to others so that they can catch up and get up to speed on what the state of the art is.
Thank you, Hannes. I hope that the questions and specifically the views of our speakers have triggered thoughts and hopefully also some provoking questions. It's time to open the floor for questions, and if there are, then please state your name and affiliation first. Is somebody handling the mic? Gentleman over there on the left, please.
Thanks. Frank Kagel from Ulm University. So I want to take up the latest point that was mentioned about education, because I think that's really the key issue and also the major challenge that we face. Because assuming everything is in place, methodologies, PETs, etc., we have to be aware that basically educating engineers is a huge task. Because, I mean, our community is big, but the engineering community may be bigger by a factor of 1,000 or more. And I want to point out the key role of universities in making this happen, because this is basically where even the people that are not primarily interested in security and privacy can be taught about. And we may even have to raise a new generation of engineers before it will really become pervasive that people think about privacy when they design such systems. And having said this, I also want to advertise a panel we are organizing tomorrow at 1 about the role of privacy in computer science education and what will be the key ingredients and the absolute essentials that we will have to have there. And Jaap-Henk will be with me on a stage together with a couple of other experts.
Yeah, I completely agree with you. When we started to work on privacy in the IETF, we also looked at how did the process work with security as we introduced security, and it turns out that it took a very long time to get from sort of the starting where nobody really knew a lot about security to having a broader awareness of what the security challenges are and how to actually do these threat analysis and to propose countermeasures. And there we were talking about in a time frame of 10 years in a standards organization. And some standards organizations aren't even that far at this point in time. So it requires, we had education sessions, we obviously had documents published that provide guidance and so on. And of course you need to do reviews and force people to a certain extent to actually go through that step, because at the beginning it's very inconvenient to actually think about those. You have to go through maybe a significant learning experience.
Thank you, Hannes. Question.
Thank you. My name is Charles Rabb, University of Edinburgh. First, let me say I'm very pleased that Marit has put up the advert for the IFIP Summer School, which is taking place in Edinburgh in August. The call for papers is already out there, and if there are any PhD students who are interested in proposing abstracts, then please react to that. The second point is that I'm struck by the computer science idea that lawyers are always kind of, well, it depends and so forth, and the answers are not clear-cut. And maybe my understanding of science is generations out of date, but I always heard about things like the uncertainty principle and about fuzzy problems and wicked problems and so on. And maybe this hasn't reached computer science yet, but maybe there's room for change there. But the question I wanted to ask particularly relates to the list of risks. the 10 important privacy risks that we saw on a slide earlier on. And this is where I want to say that in talking about the relationship between lawyers, between computer scientists, engineers, and lawyers, what is being left out of account there, and I don't say this because I'm a social scientist, is the role of social science understanding, psychological understanding, behavioral science understanding, in generating some understanding about why there may be certain kinds of risks that lawyers and engineers might be missing. For example, I'm aware that there is some research on how it is that individual people use their communication and information devices, their computers, their mobiles, and so on. And some of this research shows that one of the important risks is that people don't accept the updates that are offered in the software. And the question is, why don't they do this? Is it because they don't like it and because they fear that the thing they've got used to is now going to change, or they simply don't understand what is meant by an update? And I think it seems to me that it's only if one can understand how people use things that one can insert a third member at the table between lawyers and engineers and so on, and to understand risks better. Thank you.
Yeah, let me respond to that. I'm really glad you're making this comment because indeed in the discussion that we've been having the last hour, it is as if it's only a lawyer versus computer science thing. This is absolutely not the case, and for instance in the Privacy and Identity Lab we also have social scientists on board for exactly those reasons. And as you very rightly point out, and also actually something I said somewhere in the beginning, I think, is that one of the reasons we have very poor use of privacy-friendly technology on the internet is the fact that many of the people don't really understand how they work and that they are totally unusable. Like maybe a bit of a silly example, like things like secure email. I mean, we're left with things like PGP, and I'm a computer scientist, but I don't even know for sure whether I'm doing it right. Well, that basically means that, you know, it's hard for everybody to use. So these are very, very important things to tackle. And like you say, I mean, this is not only a lawyer thing or a computer science thing, but also human interaction designer kind of thing, social scientist kind of thing. And all these people have to be on board and are, in fact, on board whenever we do these kind of projects. Thanks.
Okay, let me maybe just add one thing about the OWASP top 10 list. I think I have to point out these are the top 10 risks, so there are for sure more risks and there might be more issues to consider, but what we also try to do to keep it quite simple, because if it gets too complicated, people probably don't use it. And if these top 10 risks are addressed, then we already are 2 steps beyond where we are today. So we also try to keep it simple, still not being aware of that's maybe just the 90% solution and not the 100% solution.
Okay, we still have room for questions.
Okay, I stole the microphone. So this is Seda Gürses from New York University, and the microphone just passed by. Okay, I have 2 questions. Yeah, exactly. So I've heard policymakers in Europe in the last year say engineers should implement data protection principles. I'm a little worried about the statement because it sees a very kind of functional role, gives a very functional role to the engineers, and also misses the point that data protection is itself very organization-centric, and a lot of the organizations are mainly compliance-centric. So I feel like this leaves out a lot of the creativity in computer science that has been proposing very interesting privacy solutions. It also doesn't address some of the things that Hannes is addressing, which is privacy at the infrastructure level, or OWASP is addressing with web applications. So that's my first question. What do you think is a good way to respond to this very limited understanding of engineers' role as people who should just implement the data protection principles? The second question is, I feel like a lot of the privacy engineering schemes that we develop are based on security engineering approaches. And I think that there's a lot happening now with the new cyber, big data, and the issues that are there. And I'm not just talking about anonymization, but issues of fairness, discrimination, and other issues. So I'm just wondering, have you been thinking about developing methodologies on that level? And great initiative, congratulations.
Yeah, thank you for the question, Seda. Indeed, on your second question, Hannes will also come in on that, I think. But That is a weakness also in my view of the current discussion that triggered by the surveillance aspect. Only security and encryption are often seriously discussed, while it's clearly necessary to go beyond. Like one of my credos is to translate data minimization into an engineering requirement in the requirements phase, and that's quite an interesting thing. And I found out that my technical interpretation is much stricter than what most lawyers would make out of the legal obligation to limit the data to what is necessary for the performance of the purpose, the task that it's collected to. So, and well, I have maybe more confidence in the creativity of engineers than some others have, because I think when engineers, and as I did when I was involved, and others still do, put their full creativity on the real problems, we will not stop having interesting and creative and new ideas, but we will have much more than we may have seen in the past.
Thank you for your second question about the methodology we have chosen, or at least the one that when we worked on this privacy consideration document, RFC, and that was really difficult at the beginning, because there was all this talk about privacy by design, and Kavukian sort of evangelized that, but nowhere you could find what that actually would mean, and so the only thing that we had at that point in time were things like privacy impact assessments, which tackled a much different space, more the development type of community rather, or the deployment community rather than the engineering community, my understanding. And also what some researchers published at that time under the umbrella of privacy engineering wasn't really adequate, because it assumed that the engineers were sort of in full control of everything in a monolithic community, which in fact they aren't. As I've shown you, it's a very fragmented community, fragmented in place and time. And so all we had at that point in time was really our experience with the security process. And we tried to tag it on to that, knowing that it of course assumes that the security process worked well, which you could probably argue maybe it didn't, but nobody really came up with other approaches. So what we have there, in addition to sort of like this classical security approach, and now with these privacy approaches, is something sort of a collection of best current practices. So you would supplement those. We have those in security, but not necessarily in privacy yet, unless we consider this upcoming work. So I think there's still some work to be done to come to a same maturity level as we have with security today.
And I'd like to enhance everything, so human rights to be implemented, but not only in technology, but also in legal systems, of course, in other system, economic, business models, everything. And our protection goals have the potential to do that, but the fairness is something where, well, society, everybody has to be part of the discussion, I guess, to figure out, do we want more or less transparency, for example, in this field or not? Right now, we are very much limited because of the data protection law, what the DPAs can do. And this is also something where we'd like to find out what should be the future role of DPAs, data protection authorities. What can they do? What should they do? Or do we need information transfer or information processing entities or human rights entities that have some, like police rules or so, some other possibilities? I think this is a totally different discussion, but it's a logic that we have to go there as well. Probably not with IPEN, but that we think already in some possibilities to change and enhance. Otherwise, if we are blocked by law limited to that interpretation, then we leave out a lot. We could use more cooperation with other human rights organizations or something like that, and perhaps have the same results, but there might also be something where, because of data protection law, we have to end our discussion. And this is not what I'm personally feeling, this is my job, but what we think we should enhance. So let's be free in discussing more. And now I hand over to our moderator.
Well, I think Seda asked two very interesting questions, and just looking at the panelists, whether there's maybe an additional contribution? Yeah, maybe? Simon?
Just the danger of the bell's rung. I think talking about this idea of handing over control to the technologist to answer all the problems is definitely not the right answer. In the same way that it wasn't the right answer to give all the controls to the legal teams or the data protection officers. Certainly the approach we're trying to promote here is everyone gets involved and brings their right strengths to the table. And certainly what we're saying is educating the engineers, they need to have at least a consideration for the implications of what their actions are. How do they code a particular system? What data does it collect? What are the implications of that as it gets progressed through the life cycle? Or perhaps little bits of code and then get embedded in larger projects.
Yeah, maybe one final comment on the security engineering approach. If there's one thing that actually I've seen in our collaboration with lawyers and social scientists is that, in fact, you very quickly discover that most of the research in privacy enhancing technologies indeed has focused on a very limited understanding of what privacy means, and that there's loads of stuff out there that we actually have only a very vague idea of how to solve in technical way, if a technical only solution would work at all. And that is also something that was actually uncovered by my work on the privacy design strategies, where you actually see that the more organizational strategies involved with processes, inform and consent, there's very, very little, concrete technology supporting those kind of aspects of privacy.
Well, thank you. That brings us to the end of our panel. I'd like to, if it's a quick question, then maybe, but there's too many. I think we were running out of time. Yeah, sorry. Achim, the floor is yours.
I would suggest that we just take all the questions and then try to respond as much as possible until the next bell rings.
Well, I just want to hear if you're going to focus on privacy charlatans. There are like a lot of companies now coming out with, oh, we have a really good privacy solution. How to trust that and how to trust what they're saying is really, really going to be a big challenge.
So I will make it short. Could we change the term privacy by design into something I would call privacy by operation?
Okay, that seems like a wrap. Thank you very much for all your attention, and thank you, Achim, for organizing this panel. Thank you.